In terms of speeds, what is meant by the refractive index of a transparent material, often given the symbol n? Well, refractive index tells us how fast light travels in that material compared to in a vacuum or in air. So that's the first thing we need to just write down here. So refractive index. Refractive index tells us how fast light travels in the material compared to in a vacuum or air. You see, light travels about the same speed in a vacuum as it does in air. So we can treat them as being more or less the same. So it's a ratio of two speeds. So our refractive index, n, is equal to the speed of light in a vacuum, speed of light in a vacuum, as we said, or air will do as well, divided by the speed of light in the material or the substance we're looking at, assuming that it's transparent. So to give you an idea here, we've got a light ray coming into a glass block. Now, glass is optically more dense than air, and so the light ray will slow down. You can see the wave fronts here. These are the wave fronts. This is the ray, the direction of that the waves are traveling, and as they enter the glass they slow down and the wave fronts bend so that the ray itself will bend and change direction. See if I can draw that as straight as I can. Okay, so there's the refracted ray. And if we were to draw a normal line in this diagram, which is 90 degrees to where the ray enters, then the angle of incidence is always between the normal and the incident ray, so that's I, and the angle of refraction is between the refracted ray and the normal. There. And so that's the refraction of light in a glass block. And because it's traveling slower in glass, the refractive index of glass is about 1.5. So n is equal to 1.5. Depends what type of glass you've got. So that means that we're traveling at a slower speed in glass compared to in air, because we have divided by a smaller number. Speed of light in the material is smaller. And to give you an idea of some other substances, air or a vacuum is equal to 1, of course, because it'll be speed of light in a vacuum divided by speed of light in a vacuum, so that will equal 1. We've got glass, as we said, which is 1.5. Water is 1.33. And so that means that light doesn't slow down as much in water as it does in glass, and therefore it won't refract as much. In diamond, light slows down quite a lot. In diamond, n, the refractive index, is 2.4. So that's very much slower than in glass or in water. And so the refracted ray would refract a great deal. It would bend through a very large angle. And that's one of the reasons why diamonds sparkle, because light gets trapped inside briefly as it gets reflected on the insides of the diamond due to the high refractive index. And that's total internal reflection, which we'll cover in another flashcard. So that's what refractive index tells us, how fast light travels in the material compared to in a vacuum, and it's the ratio of the speed of light in a vacuum, or air, divided by the speed of light in the material. Good one to remember.